Okay, so the last two sections that we covered, lessons 4.1 and 4.2, were all about simplifying rational expressions. And it was split into two, the simplifying rational expressions, so that you would just focus on adding and subtracting. Well, actually, we started off with multiplying and dividing for 4.1, and then we added and subtracted for 4.2, okay? So that was simplifying. So you are actually implementing math operations of add, subtract, multiply, and divide. I clarify the word simplifying because sometimes students mistaken one for the other when you introduce the word solving. They use it synonymously. Solving actually is finding the value of a particular variable, okay? So here, notice that now we're going to solve. You guys are going to have a rational equation on either side of the equal sign. And so when you set two rationals equal to one another, you're looking for a value of x, okay? That x value represents the intersection of both of the rational functions. So if I've graphed one and I graphed the other, I'm basically asking you, what are the x values, if there's more than one, where these two graphs cross one another? So you are using algebra to determine that, okay? So that's what your goal is going to be. So how you proceed in doing this? Well, the first thing I want you guys to do, well, actually, let me write down here so you guys can remind yourself. When asked to solve, you are finding the x value or values, because you can have more than one. So I'm going to put values in parentheses. Finding the x value of the intersection. Okay. So where are these two graphs crossing or touching one another? Okay. So we have -2 plus 1 over x plus 2 equals to x over x plus 2. Our last section in this unit 4-4 is where you're going to learn how to graph, by the way, and that will be the last section for unit 4. The first step, you'll have to write a rather small, because since it's kind of contained in space here. The first thing I want you to do is always look at your given problem, and I want you to factor wherever possible. So I need you to look at all your terms and see, is there a greatest common factor I can implement? Is there a trinomial that I can break apart into two factors, and so forth? That's the first thing you're going to do. If you look at our particular problem, none of the terms have an opportunity for us to factor. Okay, so we're going to start off just taking it easy, but the first step, always please factor wherever possible. The second step you are going to do is I need you to find your LCD, meaning your lowest common denominator. If you were to establish a lowest common denominator for each one of these expressions, what would be the lowest common denominator? X plus 2, correct. We would want every single one of those to have a common denominator of x plus 2. Whenever you guys establish what your LCD is, I want you guys to make a note that the value of, let me write this down since I can't talk, it seems. The value that your x plus 2 gives you when you set it equal to 0, that's going to be your restricted value. So if I set x plus 2 equal to 0 and solve, what I need you to tell yourself as far as restriction goes, and I'll go into more depth what this means, set this equal to 0 and solve, you are going to tell yourself, hey, x cannot equal -2, okay? This restriction is an undefined value. And what do I mean by undefined value? I mean that if you were to plug -2 into, for instance, this term right here, -2 plus 2 would give you a 0. We cannot have fractions where 0 is in the denominator. because you cannot divide by a 0. So anytime you guys establish whatever your LCD factor or factors are, each one of the factors that you tell me that the LCD is, I need you to tell yourself the restrictions as well. And you guys will understand why when I do the second problem with you guys, okay? So stand by on any questions on this one. It will come to more clarity when we do number 2 together. Is that a deal? Okay. So factor where you can, find your LCD. We'll talk about restrictions in a second. And cancel, no, sorry. What am I doing next? Oh yeah. Okay, so I'm gonna take the LCD that you got, and I want you, third step, I want you to multiply each term. But notice I'm going to write term numerator by your LCD. Okay. I need you to multiply each term, but only to the numerator. All right. You guys are accustomed of multiplying top and bottom when you are simplifying. For solving, you only do it to the numerator. So what is that going to look like? So here's what I mean by that. -2 is like saying -2/1, right? So -2 needs to be multiplied by my LCD, x plus 2. Then I'm going to put a plus for the next term. My numerator is a 1. So 1, I'm going to multiply it by x plus 2. And then I put it over the remaining part of the problem, x plus 2, equals x over x plus 2. X is my numerator, so I'm going to put the LCD with the x over x plus 2. If you have a highlighter, you can follow along with me, but here's what I want you to notice. All I did was for each term, I put the LCD right next to the numerator. That's all I did, okay? So if you remove the yellow that I just highlighted, you actually are right back where you started. That's what should happen every single time you guys insert LCD, okay? So far, you guys understand this step? Okay, so whatever your LCD or LCD factors are, just put them right next to each numerator, all right? Once you have multiplied each of the terms numerator by your LCD, I want you guys to cancel where possible. Cancel where possible. So cross out any common factors that are in the numerator and denominator. In this term, there's no opportunity to cancel. In this term right here, these factors are identical, so cross them out. On the right side of the equal sign, these factors are identical, cross them out. Okay, so the purpose of you multiplying by all the yellow factors that I just highlighted is to clean up your original equation and get rid of fractions. So watch what happens. If I distribute here, which is what is left over, I'm left with -2x minus 4. Here, only the plus 1 was left, equals, on this side, only the x was left. So now you have a straightforward linear equation. There's no fractions. There are no fractions. All I need you to do is solve for x. Just use your basic algebra skills. First of all, combine like terms if possible. Do we have any like terms we can combine? Okay. -4 and 1 is very good. So -4 and 1 makes a -3. So now -2x comes down, -3 equals x. Now you guys are going to combine, start solving if you have done all your combining. So what do you suggest we do to get those x's together? Because we need to solve for x. Add 2x is a good idea. So let's add 2x on both sides. I'm going to make an arrow over here since my space ran out. So -2x and +2x will cancel. So I'm left with a -3 on the left-hand side and a 3x on the right-hand side. And the last step, divide. So -1 is equal to x. So here is where I want you guys to understand where I need you to use the restriction. Do not box this up until you have checked to see if the x you found is restricted. So you will look back upstairs and you told yourself the only x that is not allowed is the -2. This is not a -2, so I can go ahead and put this as my final answer. So that's the x value where these two equations intersect one another. Okay? Are you guys okay with this? Okay. So I want you guys to do number 2 on your own with your partners. Okay? But before you proceed, tell me this. What's your LCD for this one? All right. So I'm going to put LCD x plus 6. Therefore, the restriction is going to be what? -6. So x cannot equal -6. So write it as an equation. And now go ahead and work this problem out on your own, or work with others, or work on your own, then consult with one another's, whatever that looks like for you. I'm going to give you about 3 minutes. All right. Okay, so what answer did you guys get? Did you get -6? All right, so was that answer allowed? No, it was not allowed. So what I want you guys to understand is when you get an answer that is restricted, okay, obviously you do not put that answer in your Delta Math homework answer. What you are going to tell me is that these two graphs basically do not ever intersect. So you are going to choose the option of no solution. Okay? No solution means the intersection never happened. Okay? These graphs never crossed. All right? So here in your notes you can remind yourself what no solution means in this particular scenario. Graphs don't intersect. Okay? And that would be your final answer. Now, just be wary because sometimes you may have more than one x as far as your answers go. And maybe if, let's say, you found 2 x's and only one of them is restricted, then you just give me the other one, okay? But in this instance, we only had 1 x, so keep that in mind. If you have no questions there, let us go to problem number 8. Let's do number 8 and then number 15, and then we should be good. Okay? All right. So that's the process. Now, sometimes you guys are going to end up with scenarios that have more than one x value as a solution. So I'm going to show you how that looks like in problem number 8. Okay? So let's work this one out. So in problem number 8, in problem number 8, what is your LCD? X minus 9 is correct. So our restricted value is going to be what? X plus 9. Right. So x cannot equals +9. Okay? All right, so any other answer works for us, but number 9 is a no-go. All right? All right, so go ahead, multiply every single numerator by x minus 9. And again, anytime you rewrite, make sure that your LCD, if removed, should look like the original problem. So if I removed every single one of those yellow positions, it should look like your original problem, okay? So don't mistakenly add too many extra LCDs. Okay, so once you've inserted your LCDs to all the numerator values, go ahead and cancel where possible. So in this case, only our second term had factors that we're able to cancel. So now we just go ahead and simplify and start distributing where possible, combining like terms, all that good stuff. So here, when you guys distribute, you are going to get x times x, which is x squared, and x times -9, which is -9x. The positive 5 is on its own. And then again here, this 3 will distribute to its factor, and you get 3x minus 27. Okay. We look to see if we have any terms to combine, and as of now, no like terms on this side and no like terms on this side. But here's what is being introduced to you. You guys just ended up with an x squared term, okay? An x squared term is what tells us that our equation is a quadratic equation. And when you guys end up with a quadratic equation, I need you to make sure you set your equation that you are looking at equal to 0. Set your equation equal to 0. So what I mean by that is that all terms must be on one side of the equal sign. Which side? I always tell students, pick the side that forces your x squared term to have a positive coefficient. This is our only x squared term, and right now it's positive, is it not? So let's move everything over to the left-hand side. So I need to move 3x over to this side. I need to move -27 over to this side. So what do I need to do to these two terms to move them? Okay, subtract 3x. And what do I do with the other one? Add 27. Good. So whatever you do on one side of the equal sign, you must do it on the other side. Just when you do it on the other side, do it with the like term. So if I subtracted 3x here, I need to subtract 3x under the 9x term. If I add 27 over here, I need to add 27 with the constant on this side. That's why it's important to combine like terms before you start moving everything, okay? So once you did that, these will zero out. So now I have it set equal to 0, just like I instructed you. Combine your like terms. So we've got x squared minus 12x positive 32. Okay. Combine vertically. Okay. So notice what happens. You guys have a trinomial. And what is it that you guys know you have to do anytime you guys get a trinomial? You've got to factor. Very good. So factor. The good news is that you get to factor where a is equal to 1. Our a coefficient, the number in front of x squared, is a 1. So it's easy to find the factors because whatever the answers are to our questioning technique, you just put them down. So the question is, what two numbers multiply to be 32 that add to be -12? -8 and -4. Cadence, very good. So you just straight write the answers down because a is 1. When a is not 1, you can't do that. And we'll do the last example, we'll do one where a is not 1. But yes, what two numbers multiply to be 32 that add to be -12? And for those of you that need the visual, some people are using big X and some people still need to write it, write it out like this. So whatever helps you remember. And so that's where she got -8, -4, okay? And once you have got there, obviously set that equal to 0 and solve. So x is going to be 8 set this equal to solve, x is going to equal positive 4. Why? Because I have to add 8 on both sides to solve for x. I need to add 4 on both sides to solve for x. Neither one of those were restrictions. Only 9 was restricted. So enter those x values into Delta Math separately. Okay? Any questions? Ready for the last one? All right, last one coming up. Number 15. Factor wherever possible. If you recall that I said that, notice here, this one here needs to be factored. What method of factoring can we use to factor that denominator? How can we factor x squared minus 6x? How can you rewrite x squared minus 6x?
X minus 3 and x minus 2.
Okay, so you're thinking of factoring a trinomial. This is only 2 terms. So it can't be a factor times another factor.
So we can factor out x.
Factor out x. What is that method called? When you factor out an x out of this, what is that? We use 3 letters. GCF. Factor by GCF. Greatest common factor. So let's rewrite that. 1 over x times x minus 6. So take out an x. Plus 1 equals negative 4x over x minus 6. So here is our actual problem that we need to focus on, right? So if you have an opportunity to factor. The first 3 examples we did together for our notes, there weren't any opportunities to factor. But remember, on the first problem, number 1, the first step I told you guys is factor where possible, okay? All right. So this one is like 1 over an invisible 1, right? So we're going to determine our LCD. So what does our lowest common denominator have to be? Very good. X parentheses x minus 6. It can't be just x minus 6 because this is a problem. So if this is the most, every single one of these has to be x minus 6. So here in this case, our LCD is going to be x times x minus 6. We want all the denominators to have an x and an x minus 6. Therefore, our restriction is going to be 2 values because you wrote 2 factors. What is this restriction going to be? A standalone x is what x value? Not 1. 0. Yep. X cannot be 0. Remember, if you set that equal to 0 and solve, if I set x equal to 0 and solve, do I need to solve anything? No. So x cannot be 0. How about x minus 6? If I set that equal to 0 and solve, what is that going to be? X is 6. So our restricted values are 0 and 6. You are allowed to get any answers and use them except for 0 and 6. All right. So let's multiply everything by our LCD. So this one here in the numerator is going to have an x and an x minus 6 next to it. Then I need to put the original denominator plus 1, put an x and an x minus 6 next to it, equals negative 4x, put an x and an x minus 6 next to it. Okay. So don't mistake this x for the x that you need to insert, okay? Because that can happen sometimes. You guys think that. So that's why I think highlighting is so important. And if you're not highlighting, just be extra careful. All right, so my highlighting says if I erased what I highlighted, I should have the original problem. So do not mistake this x for this x. Okay, those are two. This negative 4x belongs to this one. And then this x minus 6 belongs to the LCD. Okay, let us cancel where we can, and the only places we could have canceled was right here and right there. Okay, so now we just distribute. 1 is by itself. This 1x multiplies times x minus 6. And so 1x times x is just going to be x squared. And x times negative 6 is going to be negative 6x. Oh, I forgot to put my over x minus 6. None of you guys told me that. You were going to ask? Okay, yeah. Sorry about that. Yeah. Yeah, stop me if I make a mistake, because I definitely had forgotten about that. And then negative 4x times x is negative 4x squared. Okay, because you have to multiply that times that. Okay. Let me stop there to make sure everybody's okay. Any questions? We're almost done. Hang in there. All right. We have quadratics, right? We have quadratic equation here. So the rule says that when I have a quadratic equation, I must move everything over. Am I moving everything to the left of the equal sign or to the right of the equal sign? To the left. All right. So let's move this negative 4x squared over. What do I need to do to it? Add 4x squared. So let's add 4x squared to both sides. 1 plus 5x squared minus 6x equals to 0. All right, so we have a trinomial. We are going to reorder it so that we can factor it, because it's not in order from highest to lowest exponent. So let's move these things around. The 5x squared definitely should go first, so 5x squared. The negative 6x should go second, and then the constant goes last, because we want to have, you know, A, B, C as far as our coefficient values. Okay, so notice again, you do have a trinomial, and the reason I did this one more time wasn't necessarily to help you guys understand solving rational equations. It was to make sure everybody is getting this factoring bit. So notice that this trinomial you need to factor, but this time our A is not equals to 1 like the previous problem, so factoring is slightly different. Okay, you are still going to do the questioning technique of what times what and what plus what, but the values you are equaling is going to be sort of different. So what number do I put up here for the multiplication? What times what equals? 5. Okay, so 5, why? Because you have to multiply A times C. So if you are forgetting that, write AC next to your notes to remind you that when A is not 1, you are multiplying A times C. What am I trying to add to get to? What number? Negative 6. Very good. Our B value. So what were those answers? Negative 5 and negative 1 is correct. So when you get the answers, here's the biggest mistake students do. They've mistaken this for an A equals 1 process, and they come around here and they go x minus 5, x minus 1. They write the answers immediately. But that doesn't even make sense, because if you distribute these, you're definitely not getting that. First of all, x times x is x squared. You definitely don't have that, okay? So you can't do that when A is not equal to 1. You guys want to factor by grouping. So you have to rewrite this trinomial as a polynomial of 4 terms, okay? So 5x squared stays. Negative 6, which is negative 6 here, gets rewritten as negative 5 plus negative 1. That's why you did this step right here. So negative 5x minus 1x, and then the plus 1 comes down. So now I have 1, 2, 3, 4 terms that I'm able to factor by grouping. Okay, so these two right here, go right here, because if I put these together, I get -6. So now you're almost done. I factor by grouping, so I split them up. I ignore the first two, the second two, and just focus on the first two. Just don't even worry about those other two. What is the GCF of these two? 5x is correct. When I divide both of these by 5x, what do I get? X minus 1. Excellent. Now I ignore these two and I focus on the latter two. What's the GCF here? Positive or negative 1? Always take the sign of this one. Okay? So it's going to be -1. And divide both of these by -1. What do I got? X minus 1. Good. You always, always want these right here to be identical. If they are not identical, your factoring by grouping failed. Go back and figure out where your mistake is. Now you can put 2 sets of parentheses. In the first set, put the 2 GCF values, 5x minus 1. In the second factor, you put what matched, x minus 1. And now you are done to solve your factors for x. Okay, so if I set this equal to 0 and solve, some people need to write it out. Some people are doing it in their head already. I set it equal to 0, add 1 on both sides, divide by 5. So x equals 1/5 is my first x. And this one, you guys pretty much know, it's take the opposite. X equals 1. Neither one of those x values were the restrictions. Our restrictions were only 0 and 6. Neither one is 0 and 6. And you are done. Are there any questions? Okay. All right, you guys, that's it. Rest of the time is yours.